Hello, everyone. Welcome to paper session 5. We have 3 presenters in our session today. My name is Dave Brienza. I'm from the University of Pittsburgh. I'll be moderating the session. We will be recording the session and it will be available for viewing later. Welcome to everyone who's viewing the recording. I will be giving the CEU number for the session at the conclusion. Each presenter will present a PowerPoint, and then for 15 minutes, we'll have 5 minutes for a question and answer immediately following each presenter's presentation. And so we will start with Carlos Gonçalves. He will present a low-cost CAD/CAM system for complex seating applications. And so I will turn it over to Carlos now.
Okay, thanks a lot. And I'll start sharing. Can you see my screen?
Yes.
Okay, so first of all, thanks a lot for the opportunity. My name is Carlos Gonçalves. I work as rehabilitation engineer at the SARA network of rehabilitation hospitals in Brazil. It's a pleasure to present our work low-cost CAD/CAM system for complex seating adaptations. First of all, I'd like to give a little context about the institution. SARA is a network of 9 hospitals spread across Brazil. We are at most of the Brazil's regions, and we provide public service of rehabilitation free of charge for the Brazilian population. Today, I will present most of the work done at Brasilia North Lake Unit at Brasilia, Brazil. To give another context in numbers, in 2020, there were in the network more than 400,000 medical appointments, close to 12 million assistance activities by the paramedical team, and 1 million auxiliary tests for diagnosis and therapy. So with that in mind, around 2015, we wanted to increase our options for providing seating solutions for patients with severe deformities. And we have to take in mind that in all the 9 hospitals, we have seating clinics in the orthopedic workshops. So it's something with great demand in our network. CAD/CAM systems for seating solutions are not new. Like in the early 90s, there were a couple of centers or labs that did research on that, mainly using CNC milling machines that would cut hard foam made of, most of the time, polyurethane plastic. And this is work from Brienza and colleagues from '92. Nowadays, any institution can acquire a system that can provide a CAD/CAM solution for seating adaptations. You just need to have the investment for it. So most of them use a beanbag or a set of beanbags that the user is seated on. Later, those beanbags have their air removed and become rigid, where a scanner, a 3D scanner with light or infrared light, can acquire the anatomical contour of the patient. That file, that 3D file, can then be sent for a CAD, computer-aided design software, where you can design the actual cushion and backrest. Later on, another software, a CAM, computer-aided manufacturing, can convert the shape of the solution to 2 paths. You can have a robot or a milling machine that can have those paths programmed, and in the end, you have the final shape that you designed. Looking at from how it's done, here's an example where most of the time for seating applications, you have a big robot So you can scope large pieces of foam, blocks of foam, and usually you have a rough pass and then a smoother pass, so you can acquire a surface that you can already sit on, for example. But take into account the characteristics of our institution, we wanted to try something else. We tried to use as much as possible solutions that were already available or lower cost ones. So we already have staff experience in CNC machining at Sara Brasilia and Sara Brasilia Lago Norte. And we started with a common router. A router is a CNC machine that has a big build volume for working with sheets of material like wood, plastic, and metal, but it has a very short z-axis, a vertical axis. So it's good to cut things that they're not too big in height. We already were familiar with Mesh Mixer, which is a free software from Autodesk that you can edit 3D shaped forms, 3D shaped files like STL. And we acquired this software Connect, which is very low cost, and you can plug in the computer, for example, a Microsoft Kinect sensor, like from the video game, or currently an iPad with a structure sensor wirelessly. So that setup was our original work at 2015. And with that, we created a 3D seating workflow that was based on positioning and capturing, contour editing, programming and sculpting, and assembling, which is also done by the commercial applications. What is different from our approach is that we choose to use the person's wheelchair during the positioning and capturing. So it's guaranteed that it will fit in the end, and we can work out other adaptations that would be needed for the patient. It is positioning with individual beanbags, one for the cushion, one for the backrest. And later on, we can scan it with our scan and software. The contour editing is done in Mesh Mixer, and it's very visible where the patient is seated. You can see the anatomical contour very vividly in the file. And we do small offset. So we create a surface below the anatomical contour, in planning to add a soft sheet of foam over the hard foam that will be scoped. And that comes the tricky part where you separate the cushion from the backrest. And for every one of the big blocks, you need to create multiple layers that can fit the router. Someone say that's very inefficient. Well, but it is still a solution, and we can have those sets of layers scoped within a couple of hours in our current setup. Later, those files with multiple pieces of foam can be sent for a CAM software that usually nowadays runs in only one pass, because since we be placing a comfort foam over it, we don't need a very precise finish on top of the surface. And later on, we have inside a team that is with seating technicians that is very experienced. Most of them have more than 15 years in the institution. And they used to have all this cutting and gluing foam done measured by hand manually. And nowadays they receive those pieces, they glue together, they do some small adjustments, add the comfort foam, like in this picture, and it's set for test. Nowadays, the test takes only one appointment and the person receives the wheelchair in the same day of the test. So we would like to go deeper in the subject. So we created a case studies report. We acquired a sample of 13 subjects that already had an wheelchair adaptation made entirely by hand and needed a new one because of changes in the wheelchair, growth, and etc. So they were all subjects with severe deformities, and they were eligible for using this 3D seating workflow. We also made a questionnaire to evaluate the feedback of the new intervention. And also we asked the patients and caregivers the estimated maximum time while seated. So that was our major metric for this research. So until the submission of this paper back in 2018, I think, 19, we had 53 subjects that already received one adaptation using this workflow. Major of them had ages from 11 to 25 years old, and most of them were diagnostic with cerebral palsy. Since pictures speak more than graphs, here are some pictures of our solutions, our cushions and backrests still in one piece, added at Mesh Mixer. So it's very notable to see that despite being a low-cost scanning solution, you can acquire very well the contours of the patients. And also, since we are sculpting foam, the precision is not an issue for the final quality of the system. We can acquire good immersion and pressure distribution in all those cases. So the results were very well as we expected, since the sample is just a small piece of the work that we're doing throughout the network nowadays. And the patients report a better immersion, better comfort, better positioning, and also greater time on the seated position. When we inspect the results, here the absolute values and the percentage difference from the time in the manual process and also in the CAD/CAM process. So it's a small sample, but it's very clear to see that most of the patients have a very greater increase in the time while seated. And I would like to point out subject 1. It was a patient. She could stay less than an hour seated in the adaptation because of pain. And with our solution, she could stay at least for 3 hours seated. And that was a major difference for her because she could go back to school, for example, and stay there for a longer period, taking classes with the caregiver. And to conclude, this project has been running since 2015. Nowadays, we are delivering those kind of service for 3 hospitals, with everything being machined at SARA Brasilia. And some of those hospitals are at more than 1,000 kilometers from our unit. And we are shipping those pieces of foam across Brazil and helping the patients of our institution as better as we can, and with good immersion, good pressure distribution, and also maintaining the process within the sustainability of our institution. I think I was maybe too fast, but thank you a lot for the attention.
No, your timing was perfect. This was 15 minutes. So we have about 5 minutes for some discussion and questions. First of all, you're making me feel old, bringing up my 1992 reference. Thank you for that.
Well, I can say from my side, it is like an honor that you can host this presentation, and I can come up with this reference.
Thank you. So do we have any questions? We're a small group, so if you'd like to unmute and ask, you feel free to do so. Well, while people are thinking of their questions, Carlos, I had a question about the comfort foam, and what are the properties of that foam?
Usually we use viscoelastic foam, like 30 millimeters, or PU foam, polyurethane foam, with density around 45 kilograms per meters cubic.
And how do you
sorry.
No, go ahead. I thought you were finished.
It is a setup that, as I mentioned, seating adaptation at SARAs are most of the time done manually, because the institution cannot provide free of charge wheelchairs or cushions, but we can make ones. So most of the time when the patient receives recommendations or needs a new wheelchair, usually he doesn't have a cushion or backrest that it's suitable for him. So in our institution, we try our best to fix those issues within our health system, providing alternative solutions like those one. Priorly, we use a lot of man labor also with prefabricated PU backrests and seating or in cushions. And all of them, in all those years, it's very common that we add comfort foam over the rigid one, so to improve immersion. In our cases, it's very good because all of the imprecisions from scanning are kind of neglected with this approach.
And do you use a waterproof cover over that foam?
We usually don't use waterproof. One of the reasons it's would be very expensive, and you need how can I say, special equipment to sew those fabrics. But we use neoprene covers. So neoprene is a material that can stretch very well, so it doesn't blocks the immersion of the user using the cushion and the backrest. And we do it in a way that it's washable, so the person can still wash it when needed, only the cover.
Is the comfort foam layer also replaceable, or no? Because I imagine that would get, accumulate. It would get soiled.
Yes. No, it's not replaceable. How can I say? We have regular appointments with the patients. Just to give another perspective, we have patients in Brasilia that are from the Amazon, from the south, so they travel great distance to be there, but still they manage to come once a year, maybe once in 1 year and a half. So the cushions and adaptations are reviewed, and they can have maintenance or make new ones.
And it looks like we have a question from Carla.
Yes, I was just wondering, maybe it was a little bit of a follow-up question based on that because you had a whole list of positive experiences, and I was wondering if you can also say like for which users this maybe is not the best solution. Did you experience any of that?
Yes, great question. We see that in some cases, like in our research, we have it's not the best sample possible. For example, if someone needs to change their adaptation, maybe the older one doesn't fit anymore, but is not suitable anymore. So in some cases, the technicians, or in some, how can I say, less severe cases, it was not a big difference from doing it manually from doing it with CAD/CAM, right? From the workflow perspective, the thing that makes it harder is that we still need multiple employee staff to fit the person in the bean bags, because you have the sitting technician, the physical therapist, maybe myself is helping on the fitting. So that is the part where something, if can go wrong, will go wrong on that capturing phase. And we already had some patients that we need to do it over. Like they received a new one, after some days, it's not good enough. We do it again with a different positioning, but it's more on the task itself. It's not on the process. Like it's severe deformities are hard to have good immersion on, like those kind of sitting adaptations.
Thank you, Carlos. We need to move along to the next paper.
Okay.
Nice work. Our next paper will be
Thank you.
presented by Bart Van der Heyden, and he'll present content and face validation of a novel physical seating assessment technique. Bart, you can share your screen.
All right. I hope you can all see my screen. Yeah. Thank you, Dave, for the introduction, and I'm really impressed. This is almost a correct pronunciation of my name. I'm from Belgium, and Van der Heyden is my name, Bart. And we're going to talk, or I'm going to talk to you about content and face validation of a novel physical assessment technique for suprapelvic scoliosis. And I think it really fits nicely in the topic of Carlos, because Carlos talked about also partly about the capturing of the right shape. So I'm going to try to focus on that. I'm from Belgium, so the best country in the world when you like beer, chocolate, and good things in life. I studied in Ghent, most beautiful city of Belgium. And then I moved to Germany. I worked with children with cerebral palsy, and we were having always difficulties capturing the right shape, and the assessment as a therapist should inform you about this. It's always been an interest of mine to try to find the best way of doing this. I've been doing seating, wheelchair mobility, and wound care for over 25 years. I have also worked briefly in the United States. And now I have my own clinic together with my wife, and we have a staff of physical therapists. We have 5 people, and I'm also doing training, support, R&D support, and lectures worldwide. Traveling a little bit less with COVID, but online still works. So that's also my disclosure of interest. So over the years, I've seen how difficult it is to capture shape, and it's a very important part of the next phase, the actual making of the equipment, and then trialing the equipment. So I've always been looking at ways to make this more efficient, and I see clinicians and colleagues struggling worldwide with this. And then I try to work on a series of assessment techniques that I think can benefit in this whole process. So I'm going to start with the first part of the content and face validation, because I want to make sure that I get a consensus about the content and also the validity of the tool. So the first part is assessment for suprapelvic scoliosis. There's also seating techniques that I developed with infrapelvic scoliosis, so hip range of motion deficits, cervical range of motion deficits, hamstrings, and hypertone clients assessments, and even clients with a kyphotic posture. But we have to start somewhere. I think it's already quite ambitious to do this. It's not. I have never done content and face validity. So the whole purpose was to see if the proposed technique offers benefits, and then specifically to gain accurate body measurements quicker, safer, and more efficiently compared to what we currently use, if we currently use something. So in order to do this, I was advised by Mark Schmeler to actually start with a face and content validity of this technique, of my proposed technique. So just as a reminder, face validity is the extent to which the technique looks as it's relevant in solving issues when collecting data on suprapelvic scoliosis, when assessing for that. And the content is the degree to which the tool and the technique is giving you a full content and a construct that is useful in solving the problems or getting enough data when assessing for suprapelvic kyphosis, scoliosis, I apologize. So the aim, so then I think the simplest way was to create an online form, an evaluation form, which I have. So at the end, you will see a link on how you can participate. And the aim is to collect data from professionals in the seated fields, people that work with complex seating needs, ideally working for 5+ years with clients with scoliosis, suprapelvic scoliosis, occupational therapists, seating specialists, medical doctors, physical therapists, doesn't matter, as long as you have a frequent practice in evaluating suprapelvic scoliosis. So the first step of the procedure is with the survey to collect data on the current techniques. If you are using a current technique, I think feedback so far I got is that people have kind of their own technique. Sometimes some organizations and institutions have a seating evaluation form. So we're going to try to collect data on this with the form. So that's the first step. And then we're going to do survey. The survey actually runs through a couple of questions and statements where you can agree, strongly agree is one, up to strongly disagree. That would be a score of 5. And that would be questions regarding the accuracy of the data to determine if your scoliosis is fixed, partly flexible to neutral, or a flexible scoliosis. Is your technique covering this? Is your technique also giving data on the amount of lateral supports you need, the height of the lateral support on the convex and the concave side? If you also have data on the offset of the laterals on the seating system, and if you want to address a pelvic obliquity, do you have data on the amount of buildup that you need to address the pelvic obliquity? And then we're going to also ask a question or a couple of statements regarding the fact that you can you replicate with the findings from your assessment? Can you use these findings directly in your seating system, or are they just basically justifying why you are doing something? But is the data actually one-on-one transmittable into building a seating solution for your client? And also if your assessment technique gives you options, and that's going to be important when you want to address a fixed or partly flexible to neutral scoliosis, then you probably need to determine if you want to center the shoulders, and if you are centering the shoulders for function of the head or function of the shoulders, what is the impact on the pelvis, and what should you then, what height buildup should you then prescribe for your seating system? So that's what we mean with replicate, or try to find some options for your seating interventions. And we also want to know if it's safe for your client to use this technique, and if it is time involving, and what the time involvement would be. And then I was tempted to do it, but I had to slow myself down. The whole purpose of today is not to actually show you the technique. It's just to give you an idea what it is. The form or the survey will actually go in detail and provide you the steps that you need in order to have that data and actually give you the details of the proposed technique. But it is, but I give you already a little overview. We are not looking with this technique to eliminate the fitting and the adjustments when you are eventually prescribing or when you have the final equipment. That will never be eliminated. I think we still need some trialing phases, but I think it will help you to already have the right direction for the seating intervention and have accurate data. But I just want to make sure that the expectations are not too high, although they should be high. You know, there's a limitation also for the technique for high tone clients, bariatric clients, and I also think that the outcomes will need to be adjusted for gravity. The technique will collect data in a supine position, and the data you get from width and height buildup on the ischials will be accurate. But because you are using the technique in a supine environment, when you are seated, the effect of gravity will make it difficult to exactly predict it. So it is possible that you need to adjust and slowly build up a progression with the laterals offset. You know, so the offsets of the lateral might need to be adjusted for that technique. So as I just mentioned, the technique is in supine versus seated on a plinth, which most clinicians use, most colleagues use. And then you simulate your postural support devices with your hands, and that makes it a really difficult process to actually determine the exact distances and heights and measurements of the system. That makes it really difficult. A difficulty that we see as well is that the current scenarios for assessing make it really difficult to determine if it's a fixed or a part-way flexible deformity. And even if you think it's a fixed deformity, and I'm not challenging the fact that deformities cannot be fixed, but sometimes there's a degree of mobility, and that's what we mean with part-way flexible to neutral. So there is a limitation in the spine, but it is sometimes possible to reach some degree of alignment, which can benefit greatly the function of the client. So there must be a technique for exploring that, at least to see what the full potential is when addressing scoliosis. The outcomes of this new technique are distance measurements, and that's also quite unique. Typically, clinical assessments provide range of motion in degrees, which is really interesting, but a degree of range of motion is making it really hard to build a seating solution from. Because what is that in a distance measure, and where are you going to place your PSDs based on a degree of range of motion? And the technique for the suprapelvic scoliosis, you know, again, the other techniques hopefully will follow soon, is the distance measurement of the seat width, the buildup under the ITs if you need to address a pelvic obliquity, the height of the laterals on the concave and the convex side, and the amount of offset on the lateral supports on the concave and the convex side. Technique can be done by one person, which is also important in times of being short of staff. We know all about it ourselves. We need to be very efficient, and it's a time efficient technique also. And it's also safe for the client. So that's just to give you an overview on this technique. So again, at the end, you will get a QR code if you are interested, and then you can participate with the technique and the survey. And then the survey goes to the next step, and that's the almost final step. So there's 4 steps in this process. We're going to collect data to determine if the proposed technique is accurate. That's basically your content validation. Is it providing data on fixed or flexible deformities, the amount, the height, and the offset of the laterals, and the buildup on the pelvic obliquities? Are you able to produce with the distance measurements from the assessment? Can you actually produce a seating solution or a seating system that you can then trial for your client? And do you have options in case of a fixed or a part-way flexible to neutral? So a partly fixed scoliosis. Can you actually see what happens if you are favorizing symmetry of the shoulders and then give more asymmetry of the pelvis and vice versa? Can you simulate that before you actually issue the equipment? Is it safe for your client, and is the time involvement more or less than hopefully less? We will see, of course. Is it hopefully less? And then we are comparing the proposed technique with the current technique, and we basically use the same factors that I just mentioned, and you can agree or disagree on a score from 1 to 5. And I hope by now you are very interested about this technique. I sincerely hope it. So again, we are looking for professionals doing complex seating assessments, at least with a 5-year plus experience, hopefully. And there is a link to the survey. I realized the link was so long that I had to figure out a better way. And there is a QR code that you can find here. And if all goes well, if I didn't mess up, you should be going directly to the survey. And then I will be sharing the results from the survey with you, hopefully at a next event, and hopefully that will be live. So before I close the session, before I end my PowerPoint, I just want to thank the staff, our staff. They helped greatly also with the survey. And I also want to thank Rona Mode, OT and clinical specialist at Invacare, because she was kind enough to proofread my survey, which is sometimes difficult for me because in my head it's very clear, but it's not always easy to get it on paper. So that's it. So thank you.
Thanks, Bart. So remember, this presentation will be up for 1 year on the website. Will you accept it? Is it okay if people come in at a later time?
Yeah, they can come in, but I thank you for mentioning this. I probably need to have a cutoff time. So what I will do is I probably keep it up till July 1st. So I'm going to be making it long. July 1st cut out, because otherwise it's going to be a long process, So if people want to participate, you can do so before July 1st. And I leave the link here and the QR code up here, just in case. Yeah.
Great. Are there any questions? All right. So we'll bring this paper to a close. Thank you, Bart.
Thank you, Dave.
Our next paper will be presented by Alberto Nieto, and he'll present power wheelchair battery life cycle analysis based on real-world use. Alberto, you can share your screen and begin.
Thank you. Hello, everybody. My name is Alberto Nieto. I am a actually graduated from the Master's in Rehab Technology program from the University of Pittsburgh, and right now I'm an account manager for Sunrise Medical. My paper will be based on power wheelchair battery life cycle analysis based on real-world use. So a couple of things that we got in this paper are study objectives, introduction, wheelchair repairs, the power batteries, the purpose, methods, data results, discussions, limitations on this study, and the future research for it. So the objectives for this paper are to investigate the approximate time frequency power wheelchair batteries require replacement. and to investigate if there are differences between newer or older devices, the type of devices, and the manufacturers as well. So the report on disability indicates that 15% of the global population have some type of mobility impairment, and between 2 to 4% require some type of wheel mobility assistance, such as manual wheelchairs, power wheelchairs, and scooters. Wheelchairs are a really important device used by many people with disabilities worldwide, providing them with mobility and independence in their daily activities. So since wheelchairs are used daily for several periods of times, repairs are normally required to maintain the wheelchairs in excellent conditions. Studies have indicated that more than 50% of wheelchairs will need some type of repair within the 6 months of use, and people with power wheelchair will actually require more repairs in comparison to those with manual wheelchairs. So why do batteries play a really big role in this? Because batteries are used in power wheelchairs, and knowing the long-term durability in batteries will allow users, manufacturers, and durable medical equipment providers to be aware before batteries reach the end of the life cycle, and therefore the power wheelchairs just to stop working. So the purpose for this study was to investigate the real world time frequency power wheelchair batteries require replacement based on different type of situations. So the study was made between newer and older power wheelchairs, between group 2s, so standard devices, and group 3 power wheelchairs, between different group 2 manufacturers, between different group 3 manufacturers, and between the power wheelchair age and manufacturer as well. So the way the data was gathered for this study was retrieved from the Wheelchair Repair Registry. The Wheelchair Repair Registry is designed to organize a large collection of wheelchair failure and repair data collected from the labor tracker system. This is used by wheelchair technicians nationwide to document the repairs for insurance claims processing purposes. Kaplan-Meier survival analysis was conducted cumulative probability of battery failure of different groups, and Cox regression analysis was used to estimate the effects of device age and manufacturer on the hazard ratio of battery failure. So how was data obtained? Basically, any group 2 and group 3 power wheelchairs with a valid serial number purchased in or after 2016 and experienced at least one reported battery replacement was included in this analysis. So now we go through the results. There were 502 power wheelchairs used on this analysis. There were 150 group 2s and 352 group 3s. Average age of 2.7 years. And from those 502 power wheelchairs, 691 battery replacements were made. The reason for those replacements were due to batteries not holding charge, batteries dead, leaking, or cracked or broken. So comparing the group 2s and group 3 power wheelchairs, half of all battery replacements occur between 16 to 17 months of the power wheelchair purchase. Group 2 batteries are showing a longer lifespan than group 3 batteries within the first year. There is a strong relationship between the device age and battery replacement, meaning that the older devices are holding the batteries charges longer. So group 2 and group 3 older devices reduce battery replacement time by 77 compared to younger devices. So focusing on just the group 2 power wheelchairs, we had 149 Pride and Quantum, 1 Invoker. These power wheelchairs received 214 battery replacements. 50% of the battery replacements occur around 16 months after purchase. And again, batteries are lasting longer on older devices. So having older group 2 power wheelchairs are actually reducing the battery time replacement by 80%. If we go to group 3 power wheelchairs, we had 352, 230 Pride or Quantum, 110 Sunrise Medical, 8 Invoker, 3 Permoville, and 1 AMI system, with an average age of 2.67 years. Out of the 352 power wheelchairs, they received 477 battery replacements. Sunrise Medical showed the highest probability of battery replacement. 50% of their chairs require a replacement after 14 months. Pride demonstrated a lower replacement rate as well. 50% of the power wheelchairs had battery replacements after 19 months of purchase. So Again, the results for the group 3, strong relationship in batteries and power wheelchair age. So batteries are lasting longer in older devices. Group 3 devices reduce battery replacement time by 74%. Again, we have the same thing. Older wheelchairs are having the batteries replaced in longer time periods comparing to the newer ones. So this is one of the first accounting for the power wheelchair battery replacement times relative to their date of purchase. Results on average are showing 16 to 17 months of replacements after the power wheelchair was purchased, and batteries are lasting longer in older devices, and battery replacement time is reduced by 70% comparing both the group 2s and group 3's power wheelchairs. There are several style limitations. Although the sample was kind of large, it only represents a small portion of all the power wheelchair uses. So battery life cycles, averagings, and ratings can only serve as an approximation from the study. Sample sizes were not evenly distributed. We didn't have the same amount of wheelchairs, the same type of age and manufacturers that may have impacted the results. So we cannot imply that one manufacturer is better than the other one. There is no information about the size of the batteries and the manufacturer as well. And really big thing on the batteries, battery charging habits, how much time are they using the wheelchair on a daily basis, environmental factors, geographic location. Those are all really big things that can impact the battery performance in a life cycle. So the future for this paper is to including populating the wheelchair repair registry with repair data and existing and future wheel mobility and system devices to prospectively monitor the type and frequency of repairs. The labor tracker system should add more information on the variables of interest, such as battery type, brand, and size to better quantify the life cycle on these power batteries. So the conclusion of this paper, group 2s and group 3s are normally having the first battery replacement between the first 16 and 17 months. These comparisons allow the identification of risk factors leading to battery replacement based on power wheelchair age. And older devices, so 2 years or older, are showing a 77% reduction in battery replacement time versus the newer devices. So now I'm gonna go to questions.
Thank you, Alberto. I'm wondering, there did seem to be differences between the between manufacturers in terms of the months to 50% replacement. Do you think that difference could be due to the actual charging circuitry or charging systems that are used by the various manufacturers?
I think it can all depend on basically the power of the charger that they're using, and also it's really to the battery charging habits of the wheelchairs as well. So it depends. I think it's like on a person-to-person basis as to if they are doing the charges that wheelchair needs every time they need it. So that's why there are some variables that we still need to look at in the future so we can have more accurate information on it.
Go ahead, Carla.
Thank you. I was just a very nice presentation. Thank you. I was very intrigued by that the older devices seem to have this shorter battery life. Do you have any explanation? Did you think about that?
So I am not sure if it's something with the technology or the hardware or like the electronics that the wheelchair has. I think that can be a possibility as to why older wheelchairs are holding the batteries longer. But it's something that we are gonna research in the future as to what's the big that it's helping the older batteries have the older wheelchairs have the batteries for last longer than the newer ones.
Oh, awesome.
It seems like the distance traveled is a critical factor here, and it's information that you don't have from the database that you used. But I wonder if the age of the wheelchair, if there's some correlation between the age of the wheelchair and the distance that the wheelchairs are being used, that might also explain that difference.
There was a couple of comments that they want to include basically the odometer, so the miles of the wheelchairs, to see how much are they being used like on a mile basis to see if that's making a difference as well. So as mentioned on this flower, it's an approximation of the time that it has to be replaced, but there are a lot of factors that can change basically the information that we have as of right now.
Dr. Koons made a comment in the chat saying that this would be good information to give to the manufacturers. Hopefully they will tune into this presentation.
So basically the plan for this is basically to let the manufacturers know that to be aware close into the 16 to 17 months that they can start having difficulties with the batteries in the future. And also that's why they want to make this basically research a little bit more accurate, so that way you can explain even the insurances as well as to why it would be a good idea to replace them every year and a half.
Yeah, great point. I am not seeing any more questions. Are any questions for any of the presenters before we close the session? All right, well, I just want to thank all three presenters. Really great work. Thank you for sharing. And thank you for you attendees at the session. And thanks for everyone watching this recording. Take care. Enjoy the rest of the conference.
Thanks. Bye-bye.
Okay, thanks, David. Ali.